Because protons and neutrons are much heavier than electrons, nearly all of an atom's mass is concentrated in the nucleus. Think of an atom like a tiny solar system with a heavy sun in the middle and very light planets circling far away, but much, much smaller. Protons and neutrons sit packed together in the nucleus, and each one is almost 2,000 times heavier than an electron. So even though electrons move around and take up most of the space, their mass is almost nothing compared to the nucleus. The nucleus contains almost all the mass because it holds those heavy particles tightly together, while electrons form a cloud that determines size and chemical behavior but contributes very little weight. When you add up the masses, the protons and neutrons overwhelm the electrons, so the total mass of the atom comes from the nucleus. A common mistake is thinking size and mass are the same because electrons make the atom big, which leads people to assume the electron cloud must weigh a lot. So remember that volume does not equal mass, and the tiny electrons weigh far less than the nucleus. Another misunderstanding is imagining the nucleus empty even though it contains tightly bound protons and neutrons, and the binding energy and particle mass together give the nucleus its weight. So picture the nucleus as densely packed to appreciate its mass. Some students also forget to count neutrons and focus only on protons, but neutrons add weight without charge, so include both when estimating nuclear mass. Visit www.gumballdegree.com to find more videos and resources on why the nucleus holds most of an atom's mass.